Power quality refers to the stability and reliability of the electrical power supply. Issues such as voltage sags, swells, harmonics, and transients can negatively impact sensitive electronic equipment in a manufacturing environment. Surge protection is essential to prevent damage from transient voltage surges caused by lightning strikes, switching events, or equipment malfunctions. Using oscilloscope images can visually demonstrate the effects of dirty power, which is electrical power with unwanted disturbances and noise, compared to clean power, which is power that has been filtered and conditioned to remove these disturbances. A high-resolution oscilloscope image of dirty power will show erratic voltage fluctuations and distortions in the waveform. An interactive tool to simulate the effect of power conditioners can visually illustrate how these devices smooth out the waveform and reduce noise, resulting in a cleaner power supply. Transient voltage surge suppression, or TVSS, devices are designed to protect equipment from voltage spikes by diverting excess energy away from sensitive components. Oscilloscope traces can show how a TVSS device suppresses a voltage spike, clamping the voltage to a safe level. Higher-resolution oscilloscope images of TVSS suppressing multiple transients will illustrate their effectiveness in protecting against repeated surges. The Institute of Electrical and Electronics Engineers, or IEE, Standard 1100 provides recommended practices for powering and grounding sensitive electronic equipment. This standard offers guidance on mitigating power quality issues and ensuring reliable operation. A power quality guide for industrial engineers can provide further insights into identifying, analyzing, and addressing power quality problems in industrial facilities. Surges, spikes, and transient voltage disturbances are common power quality issues that can damage equipment and disrupt operations. Understanding the causes and effects of these disturbances is crucial for implementing effective surge protection measures. It is important to consider real-world examples of equipment failures caused by poor power quality or transient surges. This can include instances of damaged motors, malfunctioning control systems, or corrupted data. Emphasize the potential financial implications of downtime and equipment damage. Quantify the costs associated with lost production, equipment repairs, and data recovery. Explain how power conditioners and TVSS devices can provide a cost-effective solution to protect critical equipment and avoid costly repairs. Calculate the return on investment for implementing these measures, considering the potential savings from reduced downtime and equipment damage. Show oscilloscope images or videos to demonstrate the visual evidence of power quality issues and the effectiveness of surge protection devices. This can help to illustrate the concepts in a clear and understandable way. Encourage consulting with an electrical engineer specializing in power quality for a professional assessment and recommendations. A qualified engineer can assess the specific power quality needs of the facility and recommend appropriate solutions. To delve deeper into power quality issues, we can explore several key aspects. Firstly, harmonics or sinusoidal voltages or currents having frequencies that are integer multiples of the fundamental power frequency, typically 50 or 60 Hz. These harmonics can distort the voltage waveform, leading to overheating of equipment, malfunction of sensitive electronics, and increased energy losses. Secondly, voltage sags are short-term reductions in voltage, typically lasting from a few cycles to a few seconds. Voltage sags can cause equipment to trip offline, interrupt processes, and damage sensitive components. Thirdly, voltage swells are short-term increases in voltage, also typically lasting from a few cycles to a few seconds. Voltage swells can damage equipment by overstressing insulation and causing components to fail prematurely. Fourthly, transients are short-duration, high-amplitude voltage spikes that can occur due to lightning strikes, switching events, or equipment malfunctions. Transients can cause immediate and catastrophic damage to electronic equipment. Fifthly, grounding refers to the practice of connecting electrical equipment to the earth, providing a low-impedance path for fault currents to flow. Proper grounding is essential for safety and for preventing equipment damage from electrical faults. Sixthly, bonding is the practice of connecting different metallic parts of a system together to create a low-impedance path for current flow. Bonding helps to equalize voltage potentials and reduce the risk of electric shock. Power conditioners are devices that improve the quality of electrical power by filtering out noise, regulating voltage, and correcting power factor. These devices can help to protect sensitive equipment from damage and ensure reliable operation. TVSS devices are specifically designed to protect equipment from transient voltage surges. These devices typically use metal oxide varistors, or MOVs, to divert excess energy away from sensitive components. Online uninterruptible power supplies, or OPSs, provide continuous power to equipment, even during power outages. These devices can help to prevent data loss, equipment damage, and process interruptions. Surge protection devices, or SPDs, are similar to TVSS devices but are typically installed at the service entrance of a building to protect the entire electrical system from surges. Power factor correction capacitors are used to improve the power factor of an electrical system, reducing energy losses and improving voltage regulation. Harmonic filters are used to reduce the levels of harmonic distortion in an electrical system, preventing equipment overheating and malfunction. Regular power quality audits can help to identify and address power quality problems before they cause equipment damage or process disruption. These audits typically involve measuring voltage, current, harmonics, and other power quality parameters. Implementing a comprehensive power quality management program can help to ensure the reliable and efficient operation of electrical equipment in a manufacturing facility. This program should include measures for preventing power quality problems, detecting and diagnosing problems when they occur, and mitigating the effects of problems. The IEEE 519 standard provides recommended limits for harmonic distortion in electrical power systems. This standard can be used to assess the severity of harmonic distortion and determine the need for harmonic filters. The National Electrical Code, or NEC, contains requirements for grounding and bonding of electrical systems. These requirements are designed to ensure safety and prevent equipment damage. Article 250 of the NEC covers grounding and bonding requirements. Section 250.4 specifies general requirements for grounding and bonding. Section 250.24 covers grounding of service-supplied alternating current systems. Section 250.50 covers grounding electrode systems. Section 250.90 covers bonding of electrical equipment. Section 250.100 covers bonding of piping systems and exposed structural steel. Article 280 of the NEC covers surge arresters. Section 280.4 specifies the number of surge arresters required. Section 280.6 specifies the location of surge arresters. Section 280.41 covers connection of surge arresters. Article 285 of the NEC covers transient voltage surge suppressors, or TVSSs. Section 285.5 specifies the location of TVSSs. Section 285.6 specifies the connection of TVSSs. Table 310.16 provides ampacity ratings for conductors based on insulation type and ambient temperature. This table is used to determine the appropriate size of conductors for electrical circuits. Voltage drop is the reduction in voltage that occurs along a conductor due to its resistance. Excessive voltage drop can cause equipment to malfunction. The NEC recommends limiting voltage drop to no more than 3% for branch circuits and 5% for feeders. Power quality monitoring equipment can be used to continuously monitor voltage, current, harmonics, and other power quality parameters. This equipment can help to identify power quality problems early on so that they can be addressed before they cause equipment damage or process disruptions. Infrared thermography can be used to detect hotspots in electrical equipment, which can indicate loose connections, overloaded circuits, or other problems. Ultrasonic testing can be used to detect partial discharge in electrical equipment, which can indicate insulation breakdown. Vibration analysis can be used to detect mechanical problems in rotating equipment, such as motors and generators. Oil analysis can be used to assess the condition of insulating oil in transformers and other oil-filled equipment. Megger testing can be used to measure the insulation resistance of electrical equipment. High-pot testing can be used to verify the insulation strength of electrical equipment. Coordination studies are used to ensure that overcurrent protective devices such as circuit breakers and fuses are properly coordinated so that they will trip selectively in the event of a fault. Arc flash studies are used to assess the potential hazards of arc flash events and to determine the appropriate personal protective equipment, or PPE, that is required for working on or near energized electrical equipment. A single-point ground is a grounding system in which all electrical equipment is connected to a single grounding point. This type of grounding system can help to minimize ground loops and reduce noise. A ground loop is a condition in which multiple ground paths exist, creating a circulating current that can cause noise and interference. Shielded cables are used to reduce electromagnetic interference, or EMI. EMI can cause equipment to malfunction or produce inaccurate readings. Isolation transformers are used to isolate electrical equipment from the power supply, preventing ground loops and reducing noise. Line reactors are used to limit the rate of rise of current, protecting equipment from voltage spikes and other transient disturbances. Harmonic filters are used to reduce the levels of harmonic distortion in an electrical system. Active harmonic filters use electronic components to cancel out harmonic currents. Passive harmonic filters use inductors and capacitors to filter out harmonic currents. Static VAR compensators, or SVCs, are used to provide voltage support and improve power factor. Unified power quality conditioners, or UPCs, are used to improve both voltage and current quality. A zigzag transformer is a special type of transformer that is used to reduce harmonic currents in three-phase electrical systems. A delta-Y transformer is a type of transformer that is commonly used in power distribution systems. A Y-delta transformer is a type of transformer that is used to step down voltage from a high-voltage transmission line to a low-voltage distribution system. A neutral point of a Y-connected system is the point where the three-phase windings are connected together. The neutral conductor is the conductor that is connected to the neutral point. The grounding electrode conductor is the conductor that connects the grounding electrode to the electrical system. The equipment grounding conductor is the conductor that connects the non-current carrying metal parts of electrical equipment to the grounding system. The bonding jumper is the conductor that connects different metal parts of a system together to create a low impedance path for current flow. A ground fault circuit interrupter, or GFCI, is a device that is used to protect people from electric shock. A GFCI will trip a circuit if it detects a ground fault current of 5 mA or more. An arc fault circuit interrupter, or AFSI, is a device that is used to protect against fires caused by arc faults. An AFSI will trip a circuit if it detects an arc fault. Surge protection is an important aspect of electrical safety. Surge protection devices should be installed at the service entrance of a building and at any sensitive electronic equipment. Regular inspection and maintenance of electrical equipment is essential for preventing power quality problems. A qualified electrician should perform regular inspections of electrical equipment to identify and correct any potential problems. Power quality is an important factor in the reliable and efficient operation of electrical equipment. By implementing a comprehensive power quality management program, it is possible to minimize power quality problems and ensure the reliable operation of electrical equipment.